As a second part of the section 4.2, I'm in front of you with the graphing strategy. Okay, this is the first version. In the section 4.4, we will return to this idea with including some more details. Okay, so now let's look to this procedure. Actually, in the section 4.1, we have learned the first derivative and the geometrical meanings of the first derivative. So according to sign of the first derivative, we can decide when the graph of the function f of x is increasing or decreasing. And in this section 4.2, first part of this first part of the course related with this section, we have learned second derivative of the f is positive, means f is concave upward. Second derivative of the f is less than 0, means the graph of the f of x is concave downwards. So by constantly these two ideas, we can sketch the graph of any function. So what is our procedure? Can be expressed in the following way. So first step, analyze f of x. Find the domain at the intercept. This is always necessary, okay, to find the domain at the x-intercept and the y-intercept. You know how you can find the x-intercept. The x-intercept are the solution of the f of x equals 0, and the y-intercept is the one value, which is f of 0, because f is function, so it has to be single value. Okay. And in the second step, you should analyze the f prime. So first of all, you should find the f prime, and by finding the partition numbers for f prime, because you should analyze the f prime by calculating the sign chart, by making the sign chart, okay, and the critical numbers of f. As you know, all critical numbers are partition number, but some partition number may not be critical numbers, okay. So construct a sign chart for f prime. Determine the interval on which f is increasing and decreasing by using this sign chart, and find the local maxima and minima of f if exist. Okay. So this is related with the first derivative. Third step is related with the second derivative. So you should calculate the second derivative first of all, and similarly you should find the all partition number for f double prime. These are not called the critical point. Maybe you can say that these are the critical point for the f prime, but not important. Okay, we focused on the graph of the f of x. So it is enough to find the partition number, because all partition number are the critical number for f prime here. So you should find all partition number for f double prime. And by constructing a sign chart of f double prime, you should determine the interval on which the graph of f is concave upward and concave downward. And you can determine the point where the concavity change. This is called an inflection point, okay? So you should determine the inflection points of the f. And then by using this information which is collected from the first three steps, you can sketch the graph of the f of x function. Okay. In the furthermore topics in the future, we will discuss the asymptotes for the function. Okay. So when by adding the asymptotes idea, we will give the second version or next version of the graphing strategy with the more details. Okay. In the lecture, I will sketch the graph of the some function by using this procedure, but as I said before, in the section 4.4 we will solve more questions to sketch the graph.